Welcome back. I'm Professor M.S. Patil, and through this series of video lectures on rolling contact bearings, today we are going to talk about load-life relationship of rolling contact bearings. So first, we will see what is life of a bearing. Life of bearing, it is generally governed by the fatigue failure at the surfaces of balls and races. And therefore, when we are talking about the dynamic load carrying capacity of the bearing, it should be based on the fatigue life of the bearing. So if we talk about the life of bearing can be calculated in terms of million revolutions, or it can be calculated in terms of hours. Why these two separate units? Because most of the mechanical machine elements, they are not running at constant speed. For example, if we are talking about automobile, and therefore the bearings which are used in the automobiles, they are not operating at constant speed. So when we are talking about the life of such bearings, we have to express them in terms of number of revolutions, generally million revolutions. While there are certain machines also which are generally running at constant speed. So if machines are running at constant speed, then their life can be calculated in terms of number of hours. So if we talk about the life of an individual bearing, then it will be the number of revolutions or hours of service at some given constant speed, which the bearing runs or completes before the first evidence of fatigue crack in balls or races. If we found the first evidence of fatigue crack either in balls or races or any other parts of the bearing, then we will term it as the failure. Therefore, if the bearing completes, say, n number of revolutions, then n will be the life of that individual ball bearing. But experimentally, it is proved that though the bearings are say operating at say same conditions, same service conditions, same type of load, then also we get the uh, life of bearing differently for individual bearings. Therefore, for rolling contact bearings, we are not expressing the life of an individual bearing. Rather, we are giving it in terms of a rating life of a group of apparently identical bearings. Apparently identical bearings means the bearings identical in all sense. In all sense means the surface finish, the type of material, and all the things, they will be identical. And therefore, instead of defining the life of an individual ball bearing, we are defining the life of group of apparently identical ball bearings. And therefore, it is mandatory for us to calculate the rating life. So we will define the rating life. The rating life of a group of apparently identical ball bearings is defined as the number of revolutions that 90% of the bearings will complete or exceed before the first evidence of fatigue crack. Say if we are talking about 10 number of apparently identical ball bearings, then out of those 10, if 90% of bearings are completing or exceeding that number of revolutions, will give us the rating life. The rating life of bearings is generally denoted by L10 or B10, right? Uh, but in many number of books, you will find the term L10 used for the rating life. Rating life is also the minimum life of the bearing. So we will define or denote it by L10 for number of revolutions and L10H for number of hours. So based on this rating life, we will talk about the dynamic load carrying capacity C. This is the most important term in the selection of the bearings. So dynamic load carrying capacity C of a bearing is defined as the radial load in radial bearings. Or if it is a thrust bearing which is capable of taking axial load, then we will talk about the thrust load. So dynamic load carrying capacity of a bearing is defined as the radial load in radial bearings or thrust load in thrust bearings that can be carried for a minimum life of 1 million revolution, right? So here we are talking about minimum life. Minimum life will be the L10 life. The minimum life in this definition is the L10 life, which 90% of the bearings will reach or exceed before the fatigue failure. And this particular dynamic load carrying capacity is based on the assumption that the inner race is rotating while the outer race is stationary. In most of the bearings, inner race is rotating while outer race is stationary, but there may be some cases where inner race is stationary while the outer race is rotating. So this particular dynamic load carrying capacity C will not be applicable for such cases. This is the assumption that inner race is rotating while outer race is stationary. We can get the ready-made values of C from the manufacturer's catalog. That means directly if we refer the manufacturer's catalog, we can get the value of C for a particular bearing from that catalog. Now the third term is the equivalent bearing load P. So why it is necessary to calculate the equivalent bearing load P? Because on the bearing, whatever load is acting, that load has two components. One is radial and one is the axial component. But if we talk about the definition of C, either it takes into account the radial load or axial load. So if combinedly radial and axial loads are acting, we have to convert it into a hypothetical or virtual load P, which will be called as equivalent bearing load P. So equivalent bearing load P is nothing but the radial load, which is equivalent to that combined load. So it is therefore necessary to convert the two components, radial and thrust, into a single hypothetical load fulfilling the conditions applied to the dynamic load carrying capacity. Then this hypothetical load P, equivalent dynamic load, is defined as the constant radial load, which if applied to the bearing would give same life as that which the bearing will attain under actual condition of forces. So equivalent bearing load is nothing but it is the conversion of the combined radial and thrust load into an equivalent constant radial load, which will give us the same life. So that is equivalent bearing load, and that equivalent bearing load will be calculated by using this particular expression. P is equal to x VFR plus y FA. Here in this particular equation, x and y are the radial and thrust factors respectively, and their values can be obtained directly from the manufacturer's catalog. Here Fr is the radial load, Fa is the axial or thrust load, while V is the rotation factor. Rotation factor is equal to 1 if inner race is rotating. It will be equal to 1.2 if outer race is rotating, right? So P will be equal to XVFR plus YFA. Sometimes this particular value XVFR plus YFA is multiplied by service load if it is not possible for us to exactly predict the value of the dynamic load. Then this particular equation is multiplied by the load factor or service factor that we will see in the next lectures. So equivalent dynamic load P is equal to XVFR plus YFA. X and Y are radial and thrust factors respectively. Fr is the radial load, Fa is the axial load, and V is the rest rotation factor. which will be equal to 1 for inner race rotating and will be equal to 1.2 for outer race rotating. So till now, what we have seen, we have defined the life of bearing, we have defined the dynamic load C, we have defined the equivalent bearing load P. Then we will give the load life relationship. Load life relationship, right? It is the relationship between the two loads. C is the dynamic load, P is the equivalent load, and L10 is the life. So the load life relationship is given by L10 is equal to C upon P raised to small p. Sometimes it is referred as small a also in different books. It doesn't matters notation. So C upon P raised to P, where P is a constant, which is equal to 3 for ball bearings and which is equal to 10 by 3 for roller bearings. So for ball bearing, this equation will be equal to L10 is equal to C upon P raised to 3 times million revolutions. L10 is equal to C upon P raised to 10 by 3 million revolutions for roller bearings. We can rewrite these equations for calculating the value of C for ball bearings and roller bearings. So this is the value in million revolutions. But if we want the conversion of million revolutions into number of hours, then this simple formula for converting million revolution into number of hours or vice versa, number of hours into million revolution will be given as L10 is equal to 60 into small n into L10H divided by 10 raised to 6, where n is the speed of rotation and L10H is the rated bearing life in hours. Okay, so this is the load life relationship for the rolling contact bearings. L10 is equal to C upon P raised to P. P is equal to 3 for ball bearings and 10 by 3 for roller bearings. I hope you must have cleared all the things related to load and life of rolling contact bearings. Thank you for listening this very patiently.